Hi, in today's video, we're going to solve equations in one variables. And those equations are a little bit more complicated than the simple linear equations that we solve. Like, for example, 2 plus a 3 equals 4. You subtract 3, then divide by 2 and you solve for x. We also learned before quadratic equations. You could use x method. You could use quadratic formula to solve. You can actually find a special case and solve. Today's equations, we call them rational equations. And the reason why we call them rational, because they have fractions and some of the denominators have a variable in them. So just to quickly recall, rational functions have some restrictions. So that's the first thing I would like you guys to do when you see a fraction that has a variable on the denominator. The denominator cannot be 0. So in this case, the denominator is x and x cannot be 0 before we even start solving. Now, what are we going to use to solve? Actually, I'm going to start with example 2 because it might look more familiar to you. We see an equal sign on two sides of the equation. I see a 3, I see a 2. If I can make both sides the same, then it will be easier and we'll see how. So I'm going to do that by multiplying the first by 2, the second side by 3. Whatever I do on the denominator, I must do on the numerator. And we are going to use parentheses because the 3 is going to multiply both terms, not only the x, not only the 4. The 2 is going to multiply as well. Now that I have 6 on both sides, I can actually get rid of the denominator and just take the equation that equals numerators. So 3x plus 12. And I can treat it now just like numerator equals numerator. And I can solve it nicely. Subtract 2x. And I get 4 equals x plus 12, subtract 12, and I get x equals negative 8. When I get a solution, I always have to check my restrictions. In this case, in example 2, there are no restrictions because the denominator does not have any variable in it. So 2 is guaranteed not to be 0, 3 is guaranteed not to be 0. What if we have plus addition? When we add fractions, we also need a common denominator. Multiply by 2, multiply by 3, do the same thing on top. And this is over 1. So I want you to keep in mind that. So if I want to make this 6, I got to make also this a 6. And you're going to have to complete that so we can discuss it. Going back to number 1, this is over 1. Restriction, x cannot be 0. To make it the same denominator, what we're going to do is we're going to multiply by x. So again, once I get the same denominator, I can get rid of it as long as I put the restrictions. X multiplied by x is x squared. X multiplied by 3 is 3x. And now this goes back to a quadratic function if I rearrange it nicely. And then I use either x method. If x method doesn't work, quadratic formula. We go back to the traditional methods that we have learned. Looking at example 3, I see x plus 2, I see 1. I want to make them all the same. So I'm going to multiply the first by x plus 2, the second by x, and this one by all what it's missing, x and x plus 2. The restrictions are the denominator cannot be 0, so I have two denominators that have variable in them. So x cannot be 0 and x cannot be negative 2. Once I put my restrictions and I have all denominators the same, which is x parentheses x plus 2, I can get rid of them and make sure whatever you do on the bottom, you have to do on top. And you keep your parentheses. So the first fraction, we multiplied it by x plus 2. keep your parentheses. The second fraction, we multiplied it by x because that's what it was missing. The third one, we multiplied it by x and x plus 2. Now you're going to distribute. You're going to combine like terms. You're going to solve the quadratic. Example 4. I put the restrictions right away. X cannot be 3. X cannot be negative 3. I look at this denominator, and this is a quadratic. Once I see a quadratic denominator, I have to factor, and this is a special case. X minus a 3, x plus a 3. So the first one will multiply by x plus 3, the second by x minus a 3, because that's what it's missing from the complete big denominator. Now that I have all of them and I put my restrictions, they're all the same. I delete them and I set up the numerator, and this one we didn't multiply by anything because this is x squared minus 9. It has both the x minus a 3 and the x plus a 3. Now we distribute, we combine like terms, and solve.